Hi everyone. Today I'm going to be talking to you about precision agricultural technologies, all sorts of aspects around this, giving you a bit of an overview, but specifically talking about some of the environmental benefits which are associated with some of these technologies that you might not have heard of. So to clarify, we'll be talking about a few things, but I'll give you a bit of an overview about precision technology, what it's intended to be used for, what is considered to be a precision agricultural technology, and then I'll move on to the current uptake of precision agricultural technologies both in the UK and globally and internationally. And this will feed into the next topic, which will be having a quick look at the barriers to why uptake in precision agriculture technologies is lower than we might expect it to be, considered some of the benefits that are thought to be associated with these kind of technologies and have been demonstrated in certain cases. And then we're going to move on to looking specifically at the environmental benefits associated with these technologies. So a lot of these environmental benefits are somewhat indirect and they might not be considered, but often companies do actually highlight these as part of their sales pitch to demonstrate further use to farmers with the increasing look towards sustainability and environmental friendliness with regards to agriculture. So, precision technologies in agriculture. So what is it all about? Essentially, precision technologies at their core all rely on data. So whether it's observing, measuring, or responding to data that's been collected in a highly accurate and precise way. But what I mean by precise with regards to agriculture is that we're always moving towards higher resolution in the sense that we're looking into finer detail of various aspects of farming. So that can be a scale up. So if you think of, rather than looking at a field as a single unit and how you might apply different management practices to that field, you could scale into the individual plants within that field. Or where an animal system is concerned, rather than looking at an entire flock of animals, you can look at individual animals and apply management practices per animal or per plant basis. This doesn't have to be the case, so it could just be moving down from a farm-wide scale to an individual field scale with larger data sets for each of those. But where we think about precision agriculture, there's a really useful phrase which I've highlighted here, which is the 4 R's of precise agriculture, which is that things are applied, the right amount of things are applied in the right place at the right time, and that's a core aspect to be considering. And when you think about precision agriculture technologies, some people think that these relate solely to crop-based systems because these are the systems that have had the highest uptake to date. But actually any aspect of farming can be made precise in some way. So data can be collected and integrated into systems and management practices. And this can be key to making farming systems more efficient in the future. So what are we talking about when we talk about precision livestock technologies specifically? So the ones that would be most familiar to the majority of farmers and farm consultants and anyone related to the farm industry would be those that are utilised with crop production and pasture management. So these include many systems which relied on the increase in accuracy to do with global positioning systems, GPS, and they were integrated into systems such as self-steering tractors or assisted steering tractors, as these just made the efficiency of working a field and working crops within a field far higher, removed overlap, and improved the seeding and fertilizer application in so many ways. These were also integrated into advances in global geographic information systems. So this is the mapping that's integrated with the data, so that you could add various layers of data into a single mapped area, so that whether that would be the exact distances based on the new GPS calibrations, the nutrients that had been applied to each area, any satellite imagery mapping that would give you any information on the moisture level of the soils or the nitrogen content of the plants within that field. And then integrated on top of that, fairly commonly, is variable rate technologies for application of various different aspects, whether that be nitrogen fertilizers, whether it be seeding itself, or whether it be the application of slurry or pesticides or herbicides. So this allowed highly accurate application within different areas of a field based on previous data that had been collected. On top of this, you get all sorts of other aspects of technology that are more crop related, whether that be agricultural robots that are being produced to automatically weed rows of crop or seed them in the first instance. Connected sensors such as weather sensors to give you more data to add to your mapping systems that make future management strategies more precise with regards to crop inputs in a field or on a farm in general. And then also things like unmanned aerial vehicles provide highly accurate mapping to a higher resolution than a lot of satellite mapping. And these are becoming cheaper and can be equipped with the same kind of sensors that satellites have been able to be used for to gain information on the health, the nitrogen content, and the moisture content of soils and plants. And all of this is integrated together with usually cloud-based or software-based systems which can pull the data and often, in many cases, give specific managerial outputs based on that data. So alongside crop and pasture management based precision livestock technology applications, there are also livestock based technologies. So a lot of these are on animal devices, as you can see exemplified by this cow, but this could equally be any other livestock animal or even poultry, which have many on animal devices being developed as well. So some of the examples here being collar devices, which are often accelerometer movement based sensors, or the ear tags, which are often movement based or will also include temperature based sensors that go in ear so that you can get an idea of the animal temperature relating to health. The movement sensors all look to use behavioural cues to determine things like estrus, whether an animal is feeding correctly, or just generally behavioural changes that could be linked with illness. Then you have some other on-device animal sensors which have been developed from human-based biosensors, so such as the Band-Aid based device and the tattoo-based device. Both of these essentially look at the sweat that's coming off an animal, and there are many indicators of health and the effective utilization of feed that can be determined from the sweat of an animal. Rumen boluses are another common one, and they're used for both looking at the rumination of the animal and ensuring that nutrients is being digested and degraded efficiently, but also giving a really highly accurate core temperature of an animal, so it can be utilized for looking at illness again, as temperature changes are very prominent in various illnesses. And then vaginal boluses are being utilized to look more into fertility, as one of the big areas in both cattle and sheep based systems where losses are made productively are in effective fertility and calving and lambing of the animals. So tail-based sensors systems such as Moo-Call, which is a common one that many farmers will have come across, included here, and they help to ensure that farmers get alerted when calving is going to occur so that assistance can be given if required. And then off-animal sensors are broad as well. So you could have automated systems as part of your milking parlour. You can include weighing scales within this so that you can keep an eye on the weight gain and the health of an animal throughout its period of time and ensure that productivity is high. You can also have sensors integrated to monitor cattle, livestock in any form, lambs, poultry in farm that use that use cameras, and they can look at patterns of changes in the behavior of animals and suggest where illness or management practices might need to be changed. And there are all sorts of audio sensors which can detect pig coughs, for example, and look at illness. So these systems are broad, and they're becoming far more commercially viable now as more companies are putting a lot of R&D into these devices. So what are the benefits of precision technologies? Well, to start with, you can look at a system to an individual level. So whether that's individual plants, individual animals, individual fields, or even individual sections of a field if you separate these fields into management zones via various mapping systems and soil sampling. And this means that you can importantly apply inputs in a highly specific way that are efficient for that one individual. So this individual will get its maximal inputs, whether that's fertilizer, whether that's feed, whether that's application of treatment to cure disease, and whether that's application of water or seeding in the soils of a field. And this can mean that optimum production yields are gained, whether that's production of crop, whether that's production of meat, production of milk. All of this can be improved by applying highly specific inputs. Alongside providing highly specific inputs that are going to be most well utilized by the individual, you're also often on a whole system basis reducing your overall inputs that are being applied. So there's a cost savings association made with this in various applications of precision technologies. So you can be improving animal health and productivity, improving crop yield and production, but vitally using a lot less inputs, and this can have direct environmental benefits if the inputs have environmental impacts, such as is considered with nitrogen and slurry and various other pesticides and herbicides that are applied to crops. So if you're reducing the inputs of these, the likelihood of runoff to have an effect on the environment is lowered, and nitrogen itself can be converted into N2O, which is one of the most important greenhouse gases with regards to crop-based systems. And in animals, if you're providing feed more efficiently, then the productivity increases, and any carbon impact of that animal is actually reduced based on its relation to the productivity of the animal. So when looking at environmental benefits, variable rate technologies as a key technology was recently demonstrated in a 2020 study to actually give up to $180 economic gain back to farmers per ton of CO2 equivalent emissions abated. So it's clear that these kind of figures show that these technologies can not only improve the economic situation of a farm, they can also improve the greenhouse gas emission situation concurrently. Furthermore, of the 25 greenhouse gas mitigating strategies that were discussed in the paper, 15 of these were actually shown to be cost neutral or cost beneficial to farmers in their application. So employing these strategies could in fact not only reduce the environmental impact of farms, they could also improve the economic gains that these farms made at the same time. And several of these strategies actually could utilize precision livestock technologies in several ways. So where does this leave the current investment and uptake of precision agricultural technologies? Well, in the last 20 years, there's been an increasing uptake and an increasing investment in this area, with large companies such as Google investing $2.4 billion in agricultural tech startup companies in 2014. There's been UK agri-tech strategy initiatives that have started from 2013, which led to £70 million investments in innovative agricultural tech projects, as well as £90 million worth of investments into collaboration centres between agricultural academics and the businesses that look towards developing some of these systems further. This gradual increased investment and uptake in precision agricultural technologies is highlighted in the first graph, which shows that the estimation of this area has generally increased year on year, both in developed countries and specifically now in more developing countries as some of these technologies become cheaper and more accessible for more people. As can be seen in this second graph, based on data collected by the Farm Practices Surveys by DEFRA, there's still a gradual trend of increase from 2009 to 2016, and specifically showing that some of the largest increases are in the areas that relate to the precision cropping and precision grassland management through GPS systems, soil mapping and variable rate application as discussed previously. This is further reinforced by this second graph, which shows that whilst there's a gradual increase in almost all areas, there's a far higher level of uptake on farms in cereal and crop-based systems as compared to dairy livestock-based systems, and then in more mixed livestock and crop-based systems. Despite this, however, as you can see, the highest uptakes of any type of system on farms in the UK seems to peak around 50 to 60%, which is still a fairly low level uptake compared to many other practices and systems across farming. So what are the reasons for some of these low uptakes of these technologies by farmers? Well, there are many barriers which could be affecting farmer uptake of some of these technologies. A key one being the demonstration of the effectiveness of these technologies. Farmers want to know that they're going to have a practical outcome and a gain from using these technologies, and some of them are just so new or so fresh in their development that there's no long-term studies being available to show to farmers that they can have a massive beneficial effect in various ways. A good example of this is the robotic milking systems, which 5 years ago only 5% of farmers were taking up. And now 5 years later, with the increase in data on the increase of yields that you can achieve from milking in this fashion, the number of farms that are using these systems has in fact doubled. Another key barrier to the adoption of these technologies is the capital to invest. This is actually cited in many cases as the main barrier to the adoption of these technologies by farmers themselves. The capital investment needs to be offset by the economic gains that are achieved, and this can often take many years before the balance of investment is achieved. Whilst larger farms can spread this investment cost in a per hectare, per flock based scenario, smaller farms often struggle to justify such an investment in the first place. Another barrier to the adoption of these technologies is the training and knowledge available in the farming community. Many farmers simply aren't aware of some of the precision technologies which could benefit them with regards to some of their farming practices. And this is an area where Farming Connect and other knowledge exchange platforms can have a huge impact on informing farmers and giving them the current and up-to-date data which could assist them in making decisions on whether these technologies would be applicable to their farms. The final barrier to the adoption of these technologies revolves around the data collected by the devices themselves. A lot of this data is device specific and locked to that device or that company or that software. This means that compatibility between devices is very difficult when you're often trying to get a farm management total holistic view. You may have one device to look at one aspect of your farm and another device to look at another aspect of your farm, and then this data cannot be integrated easily together into one management software. This is one area where there needs to be a huge amount of development in the future to allow farmers to utilize one piece of equipment from one company with another piece of equipment from another company. Otherwise, there is a situation where farmers get locked into multiple contracts with multiple companies that often have rolling costs involved with them. There are also associated issues with regards to the data ownership itself. So is the data collected by the farmer able to be utilized by that farmer, or is it stored by the company and they have sole access to that data? As data in itself, as we know in the current age, is becoming a highly useful commodity with a high economic value associated to it. So what about the environmental effects of these technologies? Well, one of the main benefits of these technologies is in the potential to reduce inputs whilst increasing outputs. And one of the key ways that this is done is through improved efficiencies. A brief example of this is in GPS tractor-based control systems, where there can be an up to 70% reduction in the fuels used on farms by reducing overlap and increasing efficiency of any applications. Furthermore, the reduction of conventional fuels can be a way that these technologies can improve the environmental impact. Many of these technologies are electrical in their nature and therefore don't use conventional fossil fuels, which burn and produce a huge amount of greenhouse gases. Where electricity is the main source of power for many of these systems, including UAVs, agbots and electronic tractors, there is far more ability for this power to be produced in a renewable manner. Finally, many of these systems look to actually reduce the detrimental outputs associated with many farming practices, whether this is GPS self-steering systems associated with variable rate technologies, which can reduce the amount of nitrogen that's applied to fields, therefore reducing the amount of N2O gas that is produced. Whether this is the use of soil management strategy softwares or soil management mapping systems, which can give a better understanding of the soil health, which can be improved to then reduce the amount of runoff, which leads to pollution of waterways, for example. Or whether this is in the direct application of some livestock technologies. For example, there is now a halter system being developed for cows that will directly convert some of the methane that they release enterically into CO2, which is far less harmful to the environment. So when looking at specific crop and pasture based examples where these technologies can have beneficial impacts, a certain study that used a combination of various precision agricultural technologies, including variable rate technologies, management software technologies, and other monitoring technologies to do with crops, it was found that 368% more nitrogen was used in a conventional system compared to a precision agricultural based system. Auto steer technologies or assisted steer technologies, which are currently one of the most uptaken technologies, have been demonstrated to have higher efficiencies by 5 to 10% in terms of their application, and fuel reductions of 60 to 70% being achieved. Variable rate application technologies have been demonstrated to have beneficial effects on greenhouse gas mitigation, as well as having demonstrated effects on increasing the yields and potentials with the amount of nitrogen used by up to 8% in many studies. As well as this, there's the suggestion that there is the high possibility of moving away from fossil fuel dependent machinery with regards to crop and pasture management towards totally electric or hybrid machinery by 2030 or 2050 in the agricultural industry. With there already being designs for hybrid tractor systems that could reduce greenhouse gases produced by up to 50%. Where livestock technologies are considered, a recent study showed that increasing the uptake of technologies towards improving animal health and productivity could account for around 11% of the total possible alleviation of greenhouse gas emissions by 2050. Some examples of specific technologies that can reduce the environmental impact with regard to livestock include automated milking systems, where you have an improved yield generally compared to traditional systems, and this means that per cow and per litre of milk you're having a reduced amount of CO2 impact based on the product that you gain. Equally, many of these milking systems, through their automated nature, pre-separate out milk with certain aspects, and this can mean that processing downstream in cheese industries, for example, there's no need for further separation, and this reduces the greenhouse gases associated with the processing. Fertility detection systems such as Moo Call improve the amount of young stock that survive and then go on to produce milk or meat, and this means that there's increased efficiency of product to CO2 used. And furthermore, a study showed that having maximal fertility in cattle could actually reduce the greenhouse gas emissions by up to 20%. Illness detection systems, whether they're movement-based or image-based, regardless of the way they operate, can reduce the productivity losses that are associated with disease and illness, and therefore increase the product per greenhouse gas emission of animal ratio. Finally, precision feeding associated technologies such as automated weight scales that can look at the weight gain over time, and feeders which can detect the amount of feed taken up per individual animal, can be used to improve feed efficiencies and generally reduce feed needed across a system as a whole, and therefore lead to improved product to CO2 emission ratios per animal. So an important question in all of this is, why should farmers bother to invest in precision agricultural technologies? Well, as suggested, there's an increasing pressure in farming in the current age to move towards a more environmentally sustainable and lower impact systems of farming. Precision agricultural tools offer a viable way in order to improve productivity whilst also reducing many environmental impacts. The nature of precision agricultural technologies means that data is constantly being collected and can be used as evidence to apply for future grants and investments. This coincides well with the Agricultural Bill 2020, which has investments available where farming practices can be determined to be having a beneficial effect on the environment or protecting the environment from hazards. Finally, it's becoming increasingly difficult to get the new generation interested in farming, and therefore having sufficient labour available for farming practices to continue. Precision agricultural technologies can offer management strategies that improve productivity and efficiency whilst reducing the labour required. Through this discussion, I've given many examples where precision agricultural tools could give a beneficial effect towards reducing the environmental impact of farming practices as a whole, whilst also improving productivity and potentially improving the economic success of many farming aspects. This, however, is only a brief overview, and many other examples exist which demonstrate other potential environmentally beneficial effects. If you're interested in finding out more, feel free to follow the link to a technical article on this subject, or email me directly. Thanks for listening.